Hello guys, this is the first video for today's flipped class. This is for the flipped class Friday, December 24th. So last time in class, unfortunately we had a mishap. My battery went off and I got disconnected, and then it took us a while to be back online. In any case, we were working on something like this. Basically, the last question I asked, and I'm repeating myself for students who were on Zoom and unfortunately left us earlier, or I left them and then came back to them. I apologize. So what happened is we were talking about what are the kind of most important information you would like to extract out of this analysis. So we reached to the point here where we did the optimization problem. And because we're talking about optimization of data, definitely we're going to go under the data, under the solver. And we talked about an optimization problem consisting of the following components: an objective function, and the objective function usually we selected. This is a different sheet than the one that I worked with you on. Here, this is what we were working with. Okay. So this is the sheet. So this is the objective function, as you can see. Originally, we agreed that the objective function is the average distance, which is the sum of all these distances. And these distances, this is the distance between this vector of Adam and the whatever cluster he belongs to. And whatever cluster he belongs to is actually the cluster that satisfies the minimum distance. All right, so as we are summing all these distances and dividing them on the number of data points, which is the number of clients, that would be the average distance. For the sake of optimization, when we are dividing on a constant, the constant does nothing. We can do nothing to the constant, so there is no need for the constant, because if we optimize the sum of the distance, we optimize the whole solution, the average in general. Okay, so understanding this, excuse me, we're jumping into the second thing. We're done with the analysis. We got these crazy numbers. Nora, why did you teach us these crazy numbers? You told us there's a way to get 1 and 0 only, and there's no need for us to get these crazy numbers. So why did you teach us this? Because this is based on a relatively simpler distance measure and distance metric, which is the Euclidean distance based on the Pythagoras theory. All of you, either you are coming to take my course from the IR program, and you are very welcome. I love having IR students in my courses. Or if you come from the BE or you come from the DBI, then you definitely have taken the Pythagoras or Euclidean distance in high school, and you are still second year, third year student. I don't think you have Alzheimer by then. So hopefully you'll never have it. Nobody will have it. In any case, so this is the distance here. It's the square root of the sum of the difference of the squared difference. So the sum of the squared difference of the two vectors, or the components, the data components of the two vectors. Okay, so this is relatively easy for you to understand, and this is why I started with this, because we are starting with this whole idea of pivot table, this whole idea of lining up vectors for each cluster, this whole idea of computing a distance, then the minimum, then most importantly the match, and the match function is probably new for most of you, and then optimization problems, so many new things. I didn't want to make your life miserable and so difficult right from the beginning. So this is why. Now, Nora said that the higher the loadings, and she's using the word loadings, it's kind of like borrowed from what we call it the factor analysis. And I, in fact, provided you on Moodle with the optimal solution. So I told you, if your Excel has any problems running the solution, you can just copy the optimal solution, and minimum you should get 135.07 or less. So that is the optimal solution. And as you can see, we have used what we call it, after selecting the whole data range, we went to home and we used conditional formatting, and we used the color scales, and we used the green. You can use any other scale if you want. As you can see here, I felt the green is probably, this one is probably most decent. So here you have highlighted the highest loadings, 0.7 and above, 0.6, this 0.2, this 0.6, 0.4. So what does that tell you? This tells me that this offer belongs to this. I'm not sure. So it could tell you that. So in order to know really which offers belong to which cluster, I just selected this and went to insert and went to plotting it, and then I just love this plot. And then now looking at the plot over here, and these are actually the offers. So these, you go to the data selection, instead of 1, 2, 3, 4, it's not 1, 2, 3, 4, it's the offer number. So take the offers, so now you have on the vertical axis the offers up until 32. So it's definitely the same thing almost, yeah. Anyway, so if you have different offers that have a different serial number and not necessarily 1 all the way to 32, you have to do that. Anyway, so you can tell that here there's a peak. So offer 2. If you feel like it is easier to detect it using a different chart, we can in fact use a bar chart if you want, and then with the bar chart maybe you'll be able to detect easily which offer. So here's offer 26 here's you can see a very big peak on offer 26, a very big peak on offer 24, a huge peak on offer 17, and again on offer 2. This is for cluster 1. You can do the same for other clusters. Sorry. So here we are, I just moved the highlighted data to cluster 2. So this is cluster 2. So you can just take a look and say, okay, this is a cluster here, there's a peak, there's a cluster here, and so on. In fact, you can just add I don't want to make your life a bit difficult, but you can go to design and add the labels. So you can, but these labels are reading this rather than reading this. Oh, this is not what I wanted really. I want to know which cluster is this pretty easily. So let me check. No. 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 Okay. You just need to be a little patient. So you can see it visually here. This is cluster 6, cluster 7, cluster 12, cluster 17, cluster 28, 29. Offer 28, 29 all belong to cluster 2. So this is the first kind of type of data you want to extract, which is which offer belongs to which cluster. And this is the kind of things we were discussing when the internet was down for the Zoom people. So the first thing we were saying, with what kind of data we want to know this cluster consists of which offers. Second, we want to know which cluster each client belongs to, and it is right there. Adam belongs to 2, Allison belongs to 5, and over here Anderson belongs to 1, and so on. So we need to make a summary of all this. So let's start our investigation. Excuse me. Let's start. So this is the two kind of data. And as I showed you, you can do it here. You can say that this belongs to cluster 1 consists of offer 17, offer 24, offer 26. Cluster 2 contains this offer, maybe this offer, so I'm not sure if this offer is part of it or not. It is a bit lighter green, but that doesn't mean it's a must. In fact, this is a lighter green of cluster 2, offer 8, but offer 8 is highly loaded on cluster 3, so it's better be on cluster 3. And over here, I only have this very dark one. So it's very difficult with the k-means clustering. It's very difficult to pinpoint which cluster, which offer belongs to which cluster. So what we need to do is basically, I need to sum up, find out, based on the number of, let's delete this, so this is a new sheet here, and let's call this sheet top deals, all right? So basically, let me show you what is it that I'm trying to do. So you see the end results, and you will easily understand. So what I'm trying to do is find out how many clients are interested in each cluster for each offer. So over here, for example, for this offer number, I don't understand why they have it this way. I like to have it like that. So for this offer, for example, offer 7, we found out that for cluster 2, 12 individuals, clients are interested in offer 7 in cluster 2, but only 4 and only 3 in cluster 3 and 4. So there is overlapping. It's not that there isn't. Yeah, there are people interested in this offer in other clusters, but the highest number is in cluster 2. So we can find out, rather than looking at the loadings only, we can also take a look at the number of offers. Why? Because things start getting very shady, especially with the cluster. We had 5 clusters even. This is only for 5 clusters. So imagine with 5 clusters here, we have here 12, we have 10, we have 10 here, 13, 15, 21. But then it is still very difficult. Still, I'm not telling you it's easy. Still very difficult, especially when we have cluster 5. Look, it's very difficult to find out which offers really belong to which cluster. So I cannot function easily like that. So this is not the bestest scenario. This is not the bestest technique. We need to use the what we call it, the similarity, theta, or the distance similarity. And this will give us, instead of these decimals, it will give us 1 and 0. Okay, so let's head to, but I want you to learn this technique because we're going to use it also in the next technique, in the median, k-median. So SUMIF, we use the function SUMIF, which range? I would like you to look at the range, a certain range. Look up a criteria. Let me show you. So, in this range, right? In this range, any of them is number 1. When it's number 1, so the criteria is number 1 because I am here at cluster 1. So honestly, I need to change these into numbers. So I'm going to put here 1, 2, 3, 4, and 5. This is a very crucial step. This is a very important step. Otherwise, you won't be able to read it as a numeric. So when it is, when the client is signaled as belonging to cluster 1, and this is in this row, so in this range, when it is 1, count for me the number of people interested in offer 1. So I want to know for cluster 1, how many people belonging to cluster 1 are interested in offer 1? So over here, this guy interested in offer 1, but he belongs to cluster 4. Let me check if there's any example. Here, cluster 4 also. Here, cluster 4. Seems like we're going to get a 0. Oh man, we're going to get a 0. So when we go all the way to cluster here 4 and start the computation, how many people are interested in offer 1 belonging to cluster 4, we're going to be able to pinpoint some of the, for example, this person will belong to that, so it will be part of the counting. So did you understand what we're trying to say? So we're trying to say for sum if, you don't have to put it in capital, the range, I want you to look into this range, which is the assigned the cluster range. So looking into this range, where we assign the clusters, when it is equal to, when it's equal to, and put a comma, when it's equal, actually, you know what, guys? I want to do something with you. In fact, I would like you, stop. It's easier for everyone because a student asked me about the dollar sign and it's very difficult for you to do that. So you know what? Just highlight this. I'm going to show you something really cool with Excel. Do you see this, guys? This is called the name box. With the name box, call it CR, cluster range, CR. Just call it, you know what? Just call it cluster range. Good, and hit enter. So now this range is called CR. Okay, so let's go back. So equal sum if the range is actually this range. Okay, hit. Okay, do you see what happens? C range. So it recognized the C range. So now you don't have to worry about the dollar signs, comma. So this is the range. Criteria. Criteria is when it's when the client belongs to when it is signaled as cluster 1. So for all these who belong to cluster 1 in this range, sum for me, somewhat, sum the offers. Which offers? These offers for offer 1 because we are on the first line. This is the first line. So sum for me all those interested in offer 1 and that would be it. So you see, we didn't find anything, 0. I want to clear any conditional formatting. So just select that and put here clear rules and clear everything from selected cells. So we don't need any formatting to be carried over to this step. Okay, now again, let me explain what we're doing. We are summing the number of offers that belong to cluster, the number of offer, no, we are summing the number of the clients who belong to cluster 1 and are interested in offer 1. Okay, so let me write it down. So for cluster 1, for cluster 1, offer 1, what we are doing is we are summing the number of the clients belonging to cluster 1 and interested in offer 1. Good? So this is what we're doing. Now move it. You know how to move it, right? You just take the corner and drag the corner. Okay, So now when you move it, this moves to deal 2, this moves to deal 3, this moves to deal 4, and look, C range is the same. We don't have to put any dollar signs, and this moves to deal 5. Now we want to make sure that you know what, I should have done it also differently, because one of the students is very much concerned that she doesn't know how to use the dollar sign. But I want you to go here and add the dollar sign. So I want you to add a dollar sign here, 1, and here also add 1 after you do the copy. Or you can name this as cluster 1, C cluster 1, and name this as cluster 2, and name this as cluster 3, and name this as cluster 4. If you are not happy with using and not comfortable using the dollar signs, there is a replacement for that. So now instead of this, just refer to it as cluster 1. You see that? And also here, instead of this big bulky one, just put cluster 2. So I'm showing you more than one way. Up to you what you like. And over here, instead of putting this, now refer to it as cluster 3. And same applies here. Instead of this, refer to it as cluster 4. And the same applies to this as cluster 5. Now, I don't like the fact that we have decimal points, so you can get rid of the decimal points like this. And now, guess what? You can copy that. And that will be awesome. Because over here, this is the C range is fixed without any dollar sign. The cluster 1 is fixed without any dollar sign. The only thing that is moving is the offer. Here is 5, as you can see, and the same applies. So this 5 MC M7, which is this one. Here, 1, 2, 3, 4. Which belongs to 5, as you can see here. So this is 5MC, M2. So this is M2, M3, sorry, I was reading the wrong one, M4, M5. So it's the same here, 5. So it is consistent, you see? Here, this should be M33. So it is good. So now we have the number of clients who belong to cluster 1 and are interested in these corresponding offers, and similarly to other clusters. So if you want, you can, it doesn't make sense, if you want, you can find out how many clients are interested in offer 1, but this is easy, you already got it from the pivot table. But over here, what you're interested really in is to find out how many how many clients are interested in general in cluster 1, how many belong to cluster 1, how many clients belong to cluster 2, and how many belongs to cluster 5, 4, 3, 2, 1. So for clustering, it is very important that we don't have only 1 or 2 clients. This doesn't mean that we have a cluster. So you need to reduce the number of clusters. As you can see here, if you have only 1 or 2 clients, this means that this cluster is not substantial. There are 5 main criteria when you take clustering in marketing, or segmentation actually. Segmentation in marketing there is a criteria for an appropriate segment. It should be big enough and not that small. It should be representable and so forth. So there's a certain criteria I used to teach students when we're talking about the appropriate segment for segmentation. So the first one is it should be big enough. So this is big enough, big enough, big enough, and we don't have like 2 or 0. So then this means that we don't have a cluster. Now I don't have any problems with these guys. I do have a problem, and this is too big. We have so many clients here, but the problem is they are spread all over. So I'm not sure where or which offer to belong to where. So over here, this is maybe I'm gonna say this is the highest, this is the maximum. So over here, I'm gonna find out the maximum, or I make a match. So let's make a match and see if this match will work. So match lookup value is match this guy in which range, match this guy. This is not, no. I need to find the minimum first. So I need to find the minimum or the maximum, so that it belongs to that cluster, right? It's good. So we need to find the maximum, right? So let me take this away. So this means that this is most of the clients are in cluster 2 who are interested in offer 1. So this is the max. So here is the max, yeah? So we need to find the max. So the max here is, as you can see, for offer 3, the maximum is a 3, and 3 belongs here. So now I want to locate which cluster is that. So we can use the match exactly same way as we used it for the minimum distance, right? So the lookup value here is the maximum. In here, where is the maximum actually positioned? In which cluster? So this means this belongs to cluster 2, 1, 2, 4, and so forth. So basically, guys, this is the offer number, and this is the cluster, appropriate cluster for that offer. So now we know that offer 1 belongs to cluster 2, offer 2 belongs to cluster 1 because this is the max, and offer 3 belongs to cluster 2, and offer 4 belongs to cluster 2, and offer 5 belongs to cluster 4, and so forth. So that is awesome, right? So now we know which offer belongs to which cluster, and at the same time here we know which client belongs to which cluster. So doing this, this is very interesting. It's based on the loading of the number of clients, not the loadings that we found here, but on the number of clients. Let's take a look. So now, do you want us to make a very nice chart out of it? So click over here and insert pivot table and in existing worksheet and put it somewhere here, over here, or somewhere over here, and hit OK. And now just move like that, and now put the offer number here and put the cluster, no, where is it? Cluster here. So we have 5 clusters, right? 1, 2, 3. Where is it 3? Nobody belongs to cluster 3. Aha! You see, there's here some some situations, and this is offers here, and in here we put the count. So put the count. What we're trying to do is we're trying to aggregate. So for each offer here, what we are going to get actually the same pivot table here. It's not going to look really nice, but in any case, we're going to see which offer belongs to which cluster. So we can easily say that offer 1 belongs to cluster 2, offer 2 belongs to cluster 3, and so forth. But if you want also the opposite, you can take a look at the clusters here, cluster 1, 2, 3, 4, and you can take a look which offers. You can take out the offer if you want, and here's the count of offers. So you can see that cluster 1 has 5 offers, cluster 2 has 9 offers, cluster 4 has 7 offers, and cluster 5 has 11 offers. Oh, so we don't have any offers loading in cluster 3, and this is dangerous, you know, because we were saying that we need 5 clusters. So this is kind of dangerous, really, in a sense, and this is why another problem that emerges. So this is a nice way of seeing a summary, how many offers belong to how many clusters. So this cluster 1, as you can see, and the number of offers is 5, 9, 7, and 11, and total is 32. If you want to see which offers, then you spread it out by adding a column, so you know that offer 2, offer 17, and which offers. You don't want to know which offers because you already have it outlined for you. Then you just need the aggregation over here. So you can do the aggregation very easily with a pivot table. Now we can see that there are so many problems, but at the same time we have learned how to communicate with data. So we have learned how to do a little bit of analysis, how to communicate a problem, a mathematical problem here, or actually a natural, textual, human problem into mathematics, and also ran an optimization problem. So we knew how to translate a human problem into mathematical problem and communicate it mathematically. We also knew how to also again translate this mathematics into something humans can understand, into something that we can really present to our management and understand it. So over here, I am not satisfied with the fact that we have the loadings here. 3 has very low loadings, like very low number of offers at all time. So I'm not happy with that. In any case, regardless, let's take a look at the in the second video. We're gonna take a look at another approach, same exact thing. So you're not gonna do anything new. You're gonna copy paste and paste it. The only thing you're gonna change is the distance measure. So in this video, we learned how, in general, so far in class, we learned how to translate a human problem, which is a problem of I want to send emails, but I want to group my clients into homogeneous groups, something in common among them, and in the same way, make it systematic and automatic. So you translated this problem into mathematics, and this is what we've done. Then now that we've got the analysis, we now in this video learned how to translate this analysis, this mathematics, into something humans can understand, or can you communicate with other humans easily, those who have nothing to do or no idea how you got to the results. And actually you can use the pivot table. The use of the pivot table is basically wherever you want to start the data of the pivot table, you just select that cell and you go insert pivot table, and then basically you can insert that in a new sheet or in an existing sheet. In an existing sheet, you have to specify which location in that existing sheet and hit OK. And then once you are there, if right now I wanted to show the field view, but I cannot, so you can just go field settings, not field settings, no. I think it's something like show field list. So you can show the field list. What we've done is we put the cluster under rows and we put the offers under value, and this way we were able to aggregate how many offers belong to each cluster. All right. Thank you so much for this video. I'll see you in the next one. In the next one, we are going to do K-median clustering.